Hey there guys, welcome to this video. My name is Pushpinder Gill. So this is a data sufficiency question. So this question says, is 1 over x minus y less than y minus x? So this is what the question is asking us. So this is a yes-no data sufficiency question. And just by looking at the question, I think one thing that's coming clear to my mind is that this question is all about signs. It's all about whether x is positive or x is negative. So I'm going to take this question this way rather than trying to solve it algebraically, which is also possible to do that. So the first statement says that 1 over x is less than 1 over y. So since this is a yes-no data sufficiency question, let me just make a table where I can say x can take positive values and y can take negative values. So I can make this chart where I get 4 different types of combinations for x and y, something that we've done in our yes-no data sufficiency videos. So this is what we have. So if x is positive, y is positive, so now we will have 1 over x, which is always going to be the same thing, which is positive, positive, negative, negative. We're going to have 1 over y, which is going to be positive, negative, and positive, negative. So first of all, it has to match the question stem, that is 1 over x is always going to be less than 1 over y? Well, it is possible in this case. It's possible in this case because positive can be greater than positive. It will not be possible in this case because negative can't be greater than positive. It will be possible in this case because positive can be greater than negative. It will be possible in this case as well. So this is the only case where it is not positive. So let's see our condition. So our condition is 1 over x minus y. Is it less than y minus x? So I'm just gonna push the table a little bit to the right side, and here's what my table is. So what is going to be 1 over x minus y? So we just have to see whether it's going to be positive or it's going to be negative. So a positive number minus a positive number can actually be either positive as well as negative. So it can be both things. Similarly, y minus x, which is again two positive numbers, positive minus positive can be positive as well as negative. So I can get a yes as well as a no in this statement, depending upon the numbers I input, so which means this statement is insufficient. I don't even need to go further. So this statement is clearly insufficient. So let's just fill it out because I'm pretty sure that this is going to help me going forward in the question. So again here it's 1 over x minus y, so x minus y, so negative minus positive is always going to be negative, and y minus x is positive minus minus negative is always going to be positive, so this will always give me a yes. Negative and negative, so this is x minus y, which is negative minus negative, so this can be positive as well as negative. Similarly, both are negative here, so this can be positive as well as negative. I'm pretty sure that this is going to flip signs. You can even verify it. So this is going to be positive and negative because x minus y, which is positive minus negative, is always going to be positive, and y minus x will be the opposite sign, which is negative minus positive, which is always going to be negative. So this will always give me a no whether it suffices or not. And this one is again a yes as well as a no. So this is what we have. Let's see what statement 2 tells us in terms of sign. So statement 2 tells us that x and y carry the same sign, right? So they carry the same sign. So what are the statements which are matching the second statement as well? What are the conditions here? Let's just stretch our table a little bit, right? So if we talk about a second statement, so in second statement, both carry the same sign. So that means either this has to be true and this has to be true. So again, they both can give me a yes as well as a no, which means this is also insufficient. So now we combine both the statements. So when we combine both the statements, so we have two pieces of information. The first is that 1 over x is less than 1 over y, and the second is that 2x is equal to 3y. So what are the two conditions where again, this is not satisfied for this, this is not satisfied for this. So what are the two conditions that are satisfied for first statements as well as the second statement? Well, you can clearly see that if I want to find out combined, it's only satisfied for this, it's not satisfied for this, not satisfied for this, satisfied for this, because you can clearly see the only two ticks common to both the statements are the first and the last one. So in the first and the last one, they do carry the same signs, but I also have a difference in terms of their magnitude now. Because now if x and y carry the same sign, I can clearly figure out their magnitude. Like I can know whether x will be greater than y or x will be less than y. So if x and y are both positive, then clearly, clearly you can say that x is greater than y from here, right? You can just take them to the either side and you'll get x greater than y. If both are negative, then x is less than y. So you do have an understanding whether x is greater than y or x is less than y. So if both are positive, then x minus y is going to be positive and y minus x is going to be negative. If both are negative, then x minus y is going to be negative and this is going to be positive. So that means you will have you will have a clear understanding of whether there will be a clear answer or not, right? So in this case, x minus y, which is so x minus y, which means both are positive. Sorry, this is going to be positive as well as negative, the same thing, because the sign flip, right? So you're going to have both as positive and both are negative. You always get this to be true, so you will always be getting a no here. So which means combining both the statements, it's sufficient. Hence answer option C is my answer. So this was a tricky question, and you could have gone the algebra route as well, which is a risk-taking approach, which can work out if you understand the question in the right way. However, if you want to solve this question without even thinking too much, you can just set up this table and it will actually help you out. It will guide you throughout the question so that you can get to your answer. And in real test timings, when you're actually taking the real test, in my experience, this kind of approach helps the most in these kind of questions because it's easy to get started and it's much more organized in terms of just having the tables. But it was important to realize that this question will always be about signs. It's something that you have to recognize from experience. So thank you very much for watching this video, guys. I'll see you in the next one.